Surface area. Anytime you see surface area, it just means you're going to find the area of the sides of a three-dimensional figure or the area of a sphere around a ball, for example. We're just going to do basic examples, not doing anything that involves slants or slant hat, just basic ones. So let's start with the rectangular prism, better known as a box. Now, anytime you see SA, that's going to be surface area. And for a box, L is going to be the length, and W is the width, and H is the height. Now, it does not matter which one you call which, just stay consistent. The reason why it doesn't matter is because the box may be on this side, but you may turn it upright, which may change what you may call these sides. But just for, because we want to, we're going to call this 40 the length, we're going to call this 21 the width, and 6 is going to be the height. And basically what you're doing is finding the area of all 6 sides and add them together. That's what surface area is for a box. Now, this is the formula we're going to use, and you can use the formula or just try to picture this box with 6 sides. The front side is going to be 40 times 6, which is the same as the back side. The left side is going to be 6 times 21, which is the same as the right side. And then the bottom is 40 times 21, which is the same as the top. Or you can just use this formula, and I'm going to. So, and all this is just multiplication. 2 times L times W plus 2 times L times W plus 2, or 2 times L times H, and then plus 2 times H times W. So everywhere I have an L, I'm going to use a 40. Everywhere I have a W, I'm going to put a 21. I'm going to stay consistent. L, I said was 40. H is 6. And H, once again, is 6. And then W, we're using 21. So there's no mystery here. Just make sure you don't have the same thing twice, unless it's maybe a square-based box, something like that. But what I'm going to do is just do each one of these separately. And if you want to use a calculator, that's fine. In fact, you can use a graphing calculator and type it in all at once if you want to. I'm choosing to use a scientific calculator for now. So let's just do 2 times 40 times 21. I'm doing this all step by step, just so you can see. That's 1680. Then let's do 2 times 40 times 6, which is 480. And then 2 times 6 times 21. 2 times 6 times 21. 252. And this is only if you're using a scientific calculator. So now what I want to do is just add up those three values. 1680 plus 480 plus 252. We get 2,412. Now, when we're multiplying, we're taking a side times a side. Only one side times one side. That's millimeter times millimeter, which is the same as millimeter squared. And so that's why it also says that the units are always squared. This is area. No matter how you want to look at it, it's still area. Now let's type it in all at once in the graphing calculator. And that's 2 times 40 times 21 plus 2 times 40 times 6. I can also use parentheses. 2 times 6 times 21, as it's written down on the paper. We get the exact same answer, 2412. So either way, I'll probably be using the graphing calculator from now on. Now, this is a square prism, better known as a cube. The reason why the surface area formula is 6 times s squared, s is one of the side lengths of one of the sides. So in this case it's 32 millimeters. The reason why it's 6 times s squared is because if you find the area of one side, which is side times side, it's the same as the area of all 6 sides, so you just add them all up, or just times one side by 6. So that's what we're going to do. So we're going to use the formula 6s squared, where s is 32 millimeters squared. And I'm going to take out my graphing calculator and I'm going to type it in as 6. I'm going to use parentheses. 32. This is my square key. Enter. And we get 6,144 millimeters squared. Now, right circular cylinder like a Pepsi can, something like that. You notice that what it actually is when you do the surface area, you're going to find, think of an empty can. You're going to find the area at the bottom, which is a complete circle, that's pi r squared. And the top, if it's closed, is also pi r squared, so that's why there's two of those, 2 pi r squares. Now if you take and cut out a strip of aluminum, it's going to be an empty circle with just a circumference. The circumference is 2 pi r. Well, the word and how you get this part is if you keep on cutting them out as you go up the can. How many will you have? How many such strips would you have? Well, it depends on the height. In this case, there's h circumferences. That's where that formula comes from. And so, all you have to worry about is knowing what the variables represent. Well, r is the radius, and h is the height. And that's all you really need to know. So I'm going to take my surface area formula, and we tend to use pi is approximately 3.14. So we're going to use 3.14. So we're going to say 2 and then parentheses 3.14. In case you haven't noticed, I'm a big fan of parentheses. Radius is 34 feet. Radius is always half the diameter. The diameter is all the way across. So if I were to have this, that'd be called the diameter. But halfway across is the radius. And then plus 2 times 3.14. The radius is 34 feet. And this time we have a height which is given to be 85. If you're using a scientific calculator, do this exponent first. And if you're using a graphing calculator like I'm going to, you can just type it in all at once. I'm going to use parentheses. 2 parentheses 3.14 close, open, 34 squared plus 2 parentheses. In fact, I'm just typing in how it's written down, not changing a thing. Just want to make sure I have it typed in correctly, and if you ever see a mistake, just let me know. And we get 225,408.88, and this time it's square feet. And then we come to a sphere. A sphere is nothing but like a basketball or any kind of soccer ball, whatever. Formula actually comes from calculus. So if you think about what it actually means, 4 pi r squared, think of it as you're taking like the area of 4 circles and putting them together. It's kind of a way to think of it. Another thing to remember is the r is the radius. Now, since we're given the diameter is 30 meters, so that's all the way across. The radius is halfway across. So to get the radius, you take the diameter and divide it by 2, which is going to be 15 meters. So that's the only thing we have to worry about. So in this case, my surface area is going to be 4 times, we're going to use, instead of pi, we're going to use 3.14. And then r squared, r is 15. It's not 30, it's 15. I'm just going to use a scientific calculator just so you can see how it's going to be found. I'm going to do the exponent first. 15 squared, or 15 times 15, however you want to do it. If you know how to use your calculator, it's even better. Equals times 3.14 or 4, it doesn't matter, times 4, and we get 2826. And it is square meters. And if you want to just use your calculator, graphing calculator, just make sure. No big deal. Just going to type it in the way that it's written down on my paper. Same exact answer. And that should be the last example. And it is.